Okay, hello. So today we will solve quiz number 2 on chapter 2, which is about one-dimensional motion along a straight line. So as usual, you give the main details of your calculation, then you circle the right answer for full mark. Now the question number 1 gives you this figure, which is the velocity time graph. Velocity in meters per second and time in seconds. So the figure below shows the velocity time graph of a particle moving along the one-dimensional x-axis. Its position at 1 second is -2. So x at 1 second is -2. 1 second is here. The velocity at 1 second is 3. Question: find the position of the particle at time equals 3 seconds. Basically, find x. Okay, great. So you remember that the velocity is a derivative of position with respect to time. This means that px is v dt. That means if I integrate, so I will have delta x, of course, is integral between t initial and t final of v dt. As we said, this is an area under the curve, which curve velocity time graph, v as a function of time, between 2 points. What are these 2 points that are the boundaries? T initial and T final. And this gives me delta x. Okay, remember, this does not give me the position. It gives me the displacement, meaning it gives me x final minus x initial. So here the position I gave you is the position at 1 second, which is -2 meters. So of course, I will take my x initial be 1 and my x final to be x3. So basically the x3 minus x1 will give me the area between t 1 second and t equals 3 seconds. So let's draw that area. You see, at 1 second, this is where I start. At 3 seconds, this is where I am. So the area that I want is this area here. As you can see, this is the area I want to calculate. This area under this curve here. So this area is nothing but x3 minus x1. It's not equal to x3, okay? And be careful, you have to start it from 1, not from 0. Because I did not give you x0. If I gave you x0, there you can start from x0. But here I gave you x1 equal 1. So the area I'm concerned with this area. Okay, let's calculate this area under the curve. Well, it's straightforward. You do the calculation. So let me take this. You can calculate it in 1. So it is this area here. What is this area? It's 1 second times 3 meters per second. So it gives me 3 meters. Okay. So this is 3 meters, this is 3 meters, this is 3 meters, this is half 3 meters, and this is half 3 meters. So basically you have 4 times 3 meters. So you have 12 meters. Another way to calculate it is just to say that this is 9 meters per second. This is 3 meters per second. And this is 2 seconds. If you do the calculation, you'll get 12. So meaning x3 is equal to 12 plus x1. 12 minus 2. This gives me 10. So the answer is E, which is 10 meters. Is it clear? Okay, great. Another way to solve it is we are seeing that V is linear with time. V linear is time means the acceleration is constant. A is constant. Okay. So what's the acceleration? It's the slope of V versus T. The slope of this line, you can calculate it. Okay? So the slope will give you the acceleration, basically delta Vx divided by delta T. So I'll say 9 minus 0. I am taking it between 0 and 3 divided by 3 minus 0. So the acceleration gives me 3 meters per second squared. Okay? This is another way to solve the same problem. Acceleration is this, and it's a constant acceleration. So you can say now, okay, since it's a constant acceleration motion, I can use my classical constant acceleration equation. One of them being x at any time is x at t1 plus v at t1, t minus t1, plus half of a times t minus t1 squared. So here I will take t1 to be 1 second because I know the position. So at 1 second, what is x1? Is minus 2. So if I want x3, I'll just say that it's equal to x1, which is minus 2, times vt1. What is vt1? At t1, you know, the v is free. This is plus vt1, so velocity at 1, it's free. You can see it here. So 3 times t minus t1, so 3 seconds minus 1 second, so that's 2 seconds. That's 1/2 of 3 times 2 seconds squared. This gives me minus 2 plus 6 plus 6, and this gives you, of course, 10 meters. Okay, so the final answer is, of course, 10 meters. I think only one student or two students use this constant acceleration equation. Most of you use the area under the curve. Some of you made the mistake in calculating the area. That's number one. Second mistake is they did not take into account this minus x3. Okay, the area under the curve is delta x, is x at t final minus x at t initial. Now you are looking at the area under the curve between t initial and t final. No more, no less. Next problem. At t equals 0, a ball is thrown vertically upward from the ground into the air. The ball returns back to the ground after 2.1 seconds. Find the maximum height it reaches from the ground. Ignore air resistance. Okay. So what do we do here? Always draw. We are in physics. So let me take a red pen. Let's say this is a ground, horizontal ground. So it's like this. This is my ball. I launch it upward, vertically upward with an initial velocity v0 that I did not give you. So you have to find v0 in some sense. Okay. So it goes from the ground, reach maximum height. This is maximum height. So at maximum height, you remember the velocity is 0. He stops. And then go back down to the ground and fall on the ground. Now the velocity is reversed. will be minus v naught. Okay. Now the whole time of flight, the whole time is t, which is 2.10 seconds. Now, if you remember, the ascent time is equal to the descent time. So this time here is 2 times the time to reach the maximum height. Okay. Why? Because this ascending phase will have the same time of travel as the descending phase. We already discussed this in class. So what is the time for maximum height? It will be 1.05, basically 2.10 divided by 2. Okay. So this is the time for maximum height. Now, once I get the time for maximum height, I can use this formula. I can say that y, before I talk about y, let me just say that v at maximum height is v naught minus dt. So what is the time at maximum height? The time at maximum height is this. What is the velocity at maximum time? Is 0. So that means v naught is d time for maximum height. 9.8 times 1.05. And this gives you your initial speed, which is 10.29. This is your initial speed. Okay. Now, knowing the initial speed, what is the maximum height? Well, I will use the third equation for constant acceleration motion. V squared is equal to V initial squared minus 2d y minus y naught. Now, maximum height, this y minus y naught is the maximum height, h naught. And this v squared will be 0. Maximum height, the speed is 0. So using this, and just say that maximum height, which is y minus y naught, will be equal to what? V naught squared divided by 2g. And this formula, you know it very well, 10.29 meters per second squared divided by 9.8 times square, and this will give you the maximum height, which is 5.40. So the answer is D, 5.40 meters. Another way to solve the same problem is, once we know the V, or we can say this, we can say, oh, okay. Another way to solve the same problem. We can say Y final is Y when I return to the ground, minus Y initial, which is Y at the ground, is 0. And it's equal to V naught t squared minus half dt t squared. But this t here is 2.10 seconds. This t is 2.10 seconds. So you see that you have an equation. You know the time, you know g, the only unknown is v naught, and you will find the same answer, 10.29 meters per second. Now, knowing v naught, this is a case where you don't remember that the time for maximum height is half of the total time. We just use this formula here that we know for constant acceleration motion. The only unknown is v naught. Now, knowing v naught, you can get your maximum height, which is v naught squared divided by 2g. Okay? And of course, you will get the same answer. Great. Next problem. If the position of a point moving in one dimension is given by this x at any time is 20 times t minus 5t squared, where x is in meter. Okay, So I give you the position as a function of time, and I'm asking you to find the magnitude of the average velocity. So you know that average velocity, this is in your formula sheet. Please bring your formula sheet and use the formulas that are in your formula sheet. You know this, by the way. Average velocity is displacement divided by delta t. X final minus X initial divided by T final minus T initial. So you have to use average velocity formula between a time interval. What is a time interval? T initial is 0 and T final is a time for maximum position. Okay? So T initial is 0 and T final is the time for maximum position. So we have to find the time for maximum position. So maximum position X is when the derivative of position with respect to time, which is the velocity, is 0. So at maximum position, I will stop and then I will return back. So basically, you have to get what's the derivative of position with respect to time. You all know how to take the derivative of a polynomial function. So derivative of 20t with respect to time is 20. Derivative of minus 5t squared is just minus 10t. Remember that if I have a polynomial function, e to the power n, the derivative of that is n e to the power n minus 1. You all know this from your high school and from your math. So this is the velocity at any time. Now I want this velocity to be 0. So it's 0 when t equals 2 seconds. So the time for maximum position is 2 seconds. Okay. Now I want the average velocity between 0 and 2 seconds. So it will be x at 2 minus x at 0 divided by 2 minus 0. X at 2, I have to use this formula. I just plug. And then I replace by 2. So it will be 20 times 2 minus 5 times 2 squared. What is x at 0? X at 0 is 0, and this divided by 2. So if you do it properly, you will have 40 minus 20 divided by 2. So 20 divided by 2, this gives you an average velocity of 10 meters per second. Yeah, this is an average velocity of 10 meters per second. Be careful. I noticed that many of you missed this. Okay. So this is a typical exam question, and you know how to solve this from citation. Great. If I ask you average acceleration, so what is average acceleration? Of course, you say delta V divided by delta T. You will notice here that the average acceleration is nothing but the instantaneous acceleration. Why? Because it's a constant acceleration motion. You can see it. This is a constant acceleration motion. Okay? Right. It's equal to minus 10 meters per second square. Now, if I ask you, some of you calculated the instantaneous velocity v at any time. Okay? Well, this is just this formula here. So read carefully the problem and you answer the problem. Next question. A car accelerates from rest at 2 meters per second square for 20 seconds. This is phase 1. Step 1. Then step 2 is it then continues moving in the same direction at constant speed for 20 seconds. Okay, great. Third step or third phase, the car then decelerates at a rate of 4 meters per second square until it stops. Find the total distance. We solved this in the recitation, and I gave it as a homework as well with different numbers. So let's look at phase 1, which is a constant acceleration motion. So at t equals 0, I'll take my position x to be 0. So that's the origin. And what is V0? V0 is 0 because I'm starting from rest. Very important. I'm starting from rest. And the acceleration is constant, and I'll call it A1 is equal to 2 meters per second. Okay, great. And this phase 1 goes from x equals 0 to T1, which is 20 seconds. So the question is, what is this distance here? Is the distance x1 I'm traveling? Well, I will use an acceleration equation. So we are in phase 1. Okay. So I'll say that x1, which is x at t1, which is 20 seconds, is x0 plus v0 t1 plus half a t1 squared. X0 is 0, forget about it. V0 is 0, forget about it. And this is just half a1, which is 2 times t squared, which is 20 squared. And the first distance I'm covering is 400 meters. And so this distance is 400 meters. That's phase 1. Now, phase 2. Take another pen. Phase 2, it continues at constant speed in the same direction for another 20 seconds. So I'll go back here, always in the same direction, constant speed, meaning, of course, acceleration here is 0. Question, what is this distance here I'm traveling? Okay, so first I have to get what's the constant speed. So I'm in phase 2 now. So constant speed. So that speed, I'll call it V1. What will be the speed? The speed will be the speed at 20 seconds. So I will use this constant acceleration equation as well. It's V0 plus AT1. V0 is 0, A is 2, and T1 is 20. So you'll have a speed of 40 meters. So throughout here, you have a speed of V1, which is 40 meters. Okay. Now 40 meters per second and a constant speed. Okay, good. So the distance D2 that I'm traveling in this phase will be the constant speed V1 times the time, which is delta t, which is 20 seconds, because I'm traveling for another 20 seconds. So it will be 40 times 20. This gives you 800 meters. So the second distance is 800. Be careful here. Okay. This is also a constant acceleration equation. And this is also a constant acceleration equation. So be very careful. If you want to use constant acceleration equation here, you say that the acceleration here is 0. So you will say that, all this here, 2. So you are applying x t2 is x at t1 plus v t1 now t2 minus t1 half a t2 minus t1 squared. But acceleration is 0, so I can forget about this part. So here I will say that x2, which is xt2, sorry. So xt2 minus xt1, which is the distance that I want, d2, which is this distance here. Okay, be careful. I saw some mistakes here. It's just the v, which is vt1, which is 40, times the difference between the time. And that this time difference is given directly, equal to 20 seconds. If I wanted to say t2, it will be 40 seconds from origin, which is 0. 20 plus 20 gives you 40. But here I give you directly the delta t. The delta t, which is t2 minus t1, is 20 seconds. basically, the product will give you 800 meters. So now let's look at phase 3. This is phase 2. Now phase 3. So phase 3. So phase 3. Okay. Phase 3, I decelerate at a constant rate. So deceleration, A is negative, acceleration is minus 4 meters per second. What is the final speed? I stop. V final is 0. So the question is, what is delta? What is delta x? So here, this is phase 3. So this is the x-axis. So this is phase 3. V final is 0. I did not give you the time. I will not need it. Okay? But I want the distance between here and here. Okay, good. I know the acceleration. I know the V final. I know the V initial. V initial is 440. I'll use this formula where I don't need the time. I'll say V final squared is equal to V initial squared, which is V1 here, plus 2 times acceleration delta x. So V final here is 0. So that means delta x is minus V initial squared divided by 2 times A. It will be minus, what is the initial speed? 40 squared divided by 2 times, what is the acceleration? Minus 4. Okay, minus minus goes away, so you have 40 divided by 8, 40 squared divided by 8. And that gives you a distance of how many? So D3, which is the distance for the third phase, is equal to what? If you do the calculation properly, you find 200 meters. So this is 200 meters. So the total distance is 400 plus 800 plus 200, and of course that gives you